Thanks, Leo. Our last speaker is Louis McGibney from JPL, talking about real-time synchronous data integration across LabKey application server data using high-throughput distributed messaging systems.
Okay, folks, so I'm not going to try and pronounce this, and I'll just keep things moving. I think everybody's keen to get on. This is Pasadena in the background, JPL. I work with NASA JPL. The reason I'm here is that we work a lot with data management systems. We work a lot with high volume data, complex data, satellite data, etc. And my boss was approached in order to provide a data management solution, ongoing solutions for our current client. Where are we? There we go. So this is kind of what I'm going to just rip through just now. I don't know if I said my name's Louis John McGibney, just in case. Basically, brief outline as to why I'm here, what we're doing, the LabKey use case, and then kind of the focus of what I was wanting to talk about, which is, I think I've heard over the last day or so quite a lot of people talking about whether or not LabKey should be canonical data store for a lot of data from different application servers. And I think that's something that's kind of coming on, and I've been hearing from some people. And we've had a data integration issue. We have more than 1-2 sources of information, places that are generating data that we want to try and synchronize, because there's common attributes, there's common fields between studies and assays and things like this. Then a kind of system that we've put together that goes some length to addressing this issue, and then kind of a quick demo about what it's about, and then just kind of wrap things up. So as I'd said, we were contacted really to try and provide a data management solution for a large organisation that have many people involved in the production of clinical data, basically. They are have been using LabKey and for augmenting data as that we're all kind of familiar with here. That's why kind of I'm here, and we've been brought in to kind of produce for them, develop for them a suite of applications, going from search applications, free text search applications, down to helping them integrate stuff like LabKey and various other tools such as ISA tools, which I don't know if anybody here is familiar with, and a product that was developed at JPL called Apache ODT for data curation purposes, and workflow management, resource management, using application servers across kind of an organisation. The thing is, though, that it's important for us to recognise that LabKey is, although the data that's there is extremely important, it's just one of a number of production data, kind of the development and production environments that we see data coming from. And therefore it's important for us to be able to work with LabKey within and across a larger infrastructure. Basically, and then at the bottom there, we recently did an upgrade, rolling upgrade, and moving all this stuff kind of out to the cloud, out to AWS, and we're running on LabKey 15.2. Most of the stuff that we're developing is off LabKey trunk, and we talked about yesterday a bit about that, about how contribution models are going to hopefully be working, and how we can get more involved with pushing more of our code out and hopefully into LabKey. So this is the part that I think may be going to have some synergy with some of the people I was talking to yesterday, where, as I'd said, we've got several applications. LabKey is one of them that are generating data. And what we eventually want to do is provide kind of like a federated approach to search over all this data that's coming from various sources. For that, as I'd said, I'm not entirely sure that LabKey is the canonical source for all of this data. My main justification for that just now is that I think in collaboration possibly, or in conjunction with whoever's willing to further develop the APIs for getting data into LabKey. I thought the presentation yesterday on augmenting data models for me was interesting, because we'd experienced some issues typically even to do with like studies where studies are, and this was explained to me and had further developed it, the kind of understanding of it, that the mappings for all of these studies is split across, and all the data split across maybe many schema tables. So getting data in there currently is not as easy as it might appear. So therefore, what we want to do is right now use an external data source like Apache Solr as the canonical data source, which munges kind of all this data and does field by field mappings, such that we get from stuff like ODT and ISA tools identifiers and doing the mappings correctly, such that we're not losing data that we want to keep, such that we don't have data duplication, and such that we can deal with stuff like redundancy if and when asynchronously we wish to update fields. And really that's kind of the problem that we've been dealing with, the challenges that we've been dealing with. So SDI, here's an acronym for Synchronous Data Integration. And I'm a big kind of Apache guy. I do a lot of my code in the Apache Software Foundation, so I just go to the Apache incubator and wherever else I can to look for various technologies that are there, and I push all my code there as well. Some of the technologies we reviewed here were Apache Flume, but we ended up going with Kafka. Flume's basically a framework for moving data around, as opposed to Kafka for a messaging system, for publish-subscribe system. A lot of the technologies that are in Apache are very well tested. Everything from HTTPD web server right the way down to stuff like Kafka, which has been open sourced by LinkedIn Engineering. If you think about every single time you're making a click on LinkedIn, it's going through into the messaging system in Kafka. The whole point of this here is that it works as a log, a write-ahead log, such that you don't lose any data that you put into there, regardless of whether parts of the service are down. It's already written. When the service recovers, it retrieves these messages and it writes them in the order that they were meant to be put into the system, such that you don't lose, you don't have this, you address this data redundancy problem and you address your data duplication problems if your mappings are correct. Basically what this kind of looks like is as follows, where on the left-hand side we've got various application servers, ODT, LabKey, whatever. This can just go on and on and on. You set up a producer, which essentially binds to the source of the data coming. This is on the left-hand side. You have a consumer, which consumes data from the service. So you've got something that produces, something that consumes, typical publish-subscribe model. The consumer then pipes data into Kafka, into the write-ahead log, and into a topic, which you create. Topic could be LabKey update, topic could be Solr update, topic could be anything you want. But the point is you subscribe to topics. We can then synchronize the data and publish it in the order it should be written into Solr. This works in the other way as well, where say I want to be binding with a producer coming back out of the Kafka topic, then I can bind to that topic and I can push data with some mapping logic back into my application servers, the other application servers. So I'm addressing this data synchronization issue across my application servers, basically. And what I'd said was I wanted to just kind of show a brief kind of demo here. I realised that my demo looks like this, and I don't want to show you guys starting services and watching kind of messages going through. This just happens to be part of, where I live in the terminal. But what I wanted to just show you guys was talk you basically through kind of how this works then. We've got various components for here to deal with communication between these servers. Basically, we set these up. We create our topic, and then we install this framework that we kind of built out, all the producers, all the consumers. These are set up in different nodes. You set up a LabKey producer, and the thing is here that what I wanted to show you right now with regards to messages is that right now when we get a message out of LabKey, say you make an update, through the Java API on the left-hand side, this is just some JSON here. This is kind of what you can get out. It's almost like metadata about studies, right? We're wanting to get much more out of this, and we're wanting to be able to push much more data out and bring more in. The thing is that I think that's where we're going to really need to work to improve the APIs. And what I wanted to just finally kind of wrap up with here was the fact that the data synchronization problem for us has been something that, because we've got low volumes just now of data for this, it's kind of testing it out and building it out. It seems as if it's not going to be a problem, but for us, the penalty for potentially overwriting data or having a bunch of duplicated data in the larger architecture where we're trying to provide, as I said, federated search across a lot of these applications, the penalty for us overwriting data is, of course, huge. Something like this that builds out and scales based upon, well, it just scales because all you need to do is write a publisher and a subscriber for each of your application servers, and then it just still keeps on feeding into the queue and back out. That's pretty easy to do. So what I wanted to do here, if we can go back to presentation, I'll just wrap this one up. Thank you. I don't think the use of LabKey in it here is anything out of the ordinary. I think the workflow that we see happening, although there's various modules being used here, I don't think the LabKey use case is anything out of the ordinary. What I do think, though, is that it's important to consider that LabKey is just one component of kind of larger ecosystem. We deal with stuff like data integration a lot, and I think a lot of people struggle with data integration. Something like this is hopefully a move towards addressing that. But as I'd said, what we're keen to do is kind of work, hopefully with folk at LabKey and you know, on the discussion forums to try and drive how we can improve getting data in and out of LabKey, really. And it might be that LabKey is the canonical data source for a lot of this clinical data. I'm not entirely sure just now. But one of the maybe the most important things I wanted to make explicit here, that all of this stuff here, with some development time being the cost, all of this code, all of the software is open source. So anybody can kind of pick this stuff up, and there's a very low, I would say, probably barrier to entry, as long as you're willing to kind of learn about, you know, how to put components together. But this here kind of sets the footprint for trying to deal with data ingestion and data integration across, you know, several application servers, LabKey, of course, being one of them. And then finally, the last part is just a thank you. That's my email there. Please come and you know, have a chat with me or whatever. And if hopefully this afternoon, if there's breakout sessions or anything, there's other people kind of dealing with this, what I would like to probably do, if I can, and I think this conversation is going to go on after today, is probably touch base with the LabKey developers and see how we can, you know, move towards building out some of these APIs and getting access to the table mappings that we kind of need. And that's me. Thank you very much. Enjoy the rest of today.
Okay, thank you, Lewis, and all the speakers. We are done with lightning talks, so whoever's interested in the fundamental training, that will be happening at the classroom. That's that way. And everybody else, please find a LabKey developer and talk about things. So, thank you.